Hello, good people. Thank you for watching. Just a quick video to go over the problems from yesterday. First problem, make a histogram. You can do this one in the calculator pretty easily. You're going to begin by hitting Stat, Enter, type in the numbers. Then you're going to go second, y equals to turn on the stat plot, press Enter twice. Scroll down, select the histogram, hit Enter. Now press graph. We don't see the data because our graph needs to match this graph paper here. So I'm going to change the minimum to 70, my x minimum, and I'm going to change my x max to match this number, 87. So I'm hitting window, changing that minimum to 70, maximum to 87, like it says there. X scale, I want it to count by twos, and I'm going to change the y min to -1 and the y max to 6. Now when I press graph, it looks nice. If you hit trace, you can move around on the graph and it'll tell you the height of each interval. That was pretty fast. Also, you can easily do this one by hand by, counting how many numbers are between 70 and less than 72. There's no numbers. How many numbers are greater than or equal to 72 and strictly less than 74? There's just that one number, the 73. All right, next question was asking us to determine the mean and the standard deviation of that data. Find the mean. Find the standard deviation. I'm just going to use the calculator since I had already typed it in. So we already typed it in stat. We're here. The next thing that you want to do is to just press stat over to the right, and then you're going to calculate that first one, the one variable statistics. Scroll down and press calculate. You got it. That top X bar is your mean. So the mean is 78.4 inches. So that's the average basketball player height there, with a standard deviation of 3.01 inches. They say round to the nearest tenth, so I guess 3.0 inches. Is it appropriate to use the mean and the standard deviation to summarize these data? Definitely, yes. It was very symmetric. It was about almost perfectly symmetric, and it's unimodal, so it's appropriate to use the normal model and the mean and the standard deviation to summarize the center and spread of the data. Sketch a curve. All right, so I centered my curve here at 78.4, and then I counted by 3, my standard deviation, 3 times in each direction. How many of the numbers in the data set actually fall within one standard deviation of the mean? We have to look. We're asking ourselves how many of these numbers are between 75.4 and 81.4. So I'm just going to circle all of them. 75 is just below 75.4, so it doesn't qualify. 82 doesn't work. 81 is within that interval. 76 is within that interval. 81. 79 is within that interval. 74 is not. 78 is. 81 is. 79 is. 78 is. 77 is within that interval. 82 is not. 79 is. 77 is. 75 is not. 76 is. So it looks like we circled 14 or 13 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 numbers were circled. Just double checking real quick. Yep. So 13 of the numbers are actually within one standard deviation of the mean. It's supposed to be 68% of the data. Let's see what that actually is. 13 out of 20 numbers. That was 65% of those basketball players' heights were within one standard deviation, which is pretty close to what the normal model predicts. All right, new problem, copy machines. Manufacturer claims that the lifespans of their copy machines can be described by a normal model with an average of 42 months and a standard deviation of 7 months. Draw and clearly label the model. So we're going to center it at 42 months, and then we're going to count by 7 months. 42 plus 7 is 49. 49 plus 7 is 56, and so on and so forth. About what percent of these copiers will last longer than 49 months? So longer than 49 months is right here. And we've memorized this tale by now. It contains about 16% of the data. If you don't have it memorized, you can figure it out by subtracting out this middle 68 from 100. 100 minus 68 leaves us with 32. That's spread evenly here and here. In this case, we don't want both of those green tails. We just want the red one. So we're going to cut that in half, and that's where we get our 16 from. New problem. About 95% of these copiers will last between blank and blank months. The cutoff values that bound the middle 95% are right here. You can see them. 28 months and 56 months. So 95% of these copiers will have lifespans between 28 months and 56 months. What percent of these copiers are expected to fail before 36 months? Alrighty, so 36 months isn't quite here. If it was 35 months, the answer would be about 16%. But we can see that this contains a little bit more data than that. So our answer should be more than 16. All right, this is when we're going to use that calculator. Whenever it asks for an exact amount like this, use the calculator's inverse norm or normal CDF feature. So I hit second vars, and because they're giving us a cutoff value 36 and we have to calculate a percent, we're going to do second vars 2, normal CDF. We're going to leave that lower bound as negative infinity, and we're going to set our upper bound as 36, which is what the problem's asking us. Specify the mean of 42 months and the standard deviation of 7 months. Hit paste, and we have our answer. 19.6%. We would expect 19.6% of these copiers to fail before 36 months. So 36 months is 3 years. 20% of these roughly are going to fail before they're 3 years old. I'm going to stop the video here because I have students rolling in. Stay tuned for part 2 of this video. Thank you.